Nosocomial infections are infections acquired during hospitalization or work in a medical institution. Pathogens of nosocomial infections can be transmitted from person to person, through the environment or contaminated water and food, through the skin or contaminated items of medical personnel, as well as through shared items and surfaces, mainly textiles. Analysis of the statistical data on the safety of patients obtained by the World Health Organization allows to draw alarming conclusions. Nosocomial infections can be found in 1 out of 10 patients. They cause 3 million deaths every year, and a significant part of the healthcare budget is spent on fighting these infections. Some groups of patients are particularly vulnerable: newborns, elderly people, patients with severe underlying pathology and multiple concomitant diseases. To date, it is absolutely clear that the traditional types of cotton medical textiles and scrubs are not a barrier to infection. In this regard, an urgent task is to develop a method for improving textile quality, in particular ensuring additional antibacterial properties. Vladimir says the proposed technological process has the following advantages. First, it is essentially a one-step process, and our developed equipment is compact and consumes a relatively small amount of energy. Second, there are no emissions of nanoparticles applied to textiles from the process zone. That is, the process is environmentally friendly. Third, the process expenditure is quite low. Fourth, we managed to shift from using expensive silver and replace it with cheap zinc oxides. A very important point is that the textile material obtained via this process can be repeatedly washed. All the aforementioned points are crucial and enable us to be optimistic, saying that a whole range of different material has been developed for use in different conditions. One-step process: compact, eco-friendly, energy-efficient, reasonable cost, successful development and implementation of production technologies for nanomaterials calls for the joint work of specialists in different areas: chemists, physicists, technologists, engineers. Moreover, the application of nanomaterials in modern medical practice will certainly require a contribution from biologists, physicians, pharmacists and other specialists directly interested in the materials being developed. But as a first step, it was necessary to create pilot plants, where it would be possible to start testing real processes. This step was successfully taken at the Institute of General and Inorganic Chemistry of the Russian Academy of Sciences, within the framework of the contractual work aimed at creating innovative products. The plant consists of the following units: fabric winding unit, a unit for applying nanoscale antibacterial compositions obtained by Sol-Gel method inside an ultrasonic field to the surface of textile materials, neutralization unit, washing unit, drying unit, fabric wrapping unit. Ultrasonic source: the process yields textile materials with bactericidal nanocoating. The results of studies of bactericidal properties show that when contacting the surface of such material, all kinds of microorganisms that cause nosocomial infections die. The main advantage of the approach is the ability to apply nanoscale antibacterial compositions of various compounds to the surface of textile materials, which allows to quickly respond to the constant evolution of microorganisms that gradually adapt to any formulations of bactericidal coatings. This project is a result of the joint work of InfoMed-Pharm Dialogue and the Institute of General and Inorganic Chemistry of the Russian Academy of Sciences, with the financial support of the Foundation for promoting the development of small scientific and technical enterprises.